Greetings everyone. This is Akash Junarkar Janam Fagania and Suzana Adhikari from Sardar Patel Institute of Technology. Our topic is spam classification via machine learning algorithms, and our guide and co-guide are Professor Priya Deshpande and Professor Deepak Karya, respectively. So, the problem statement is to develop a comprehensive and efficient spam classifier using semantics and natural language processing for classification of spam and ham in mails. The objectives are as follows: to accurately distinguish spam from ham, text classification and URL filtering and analysis, and thirdly, hence to create a comprehensive system for spam classification and filtering. Siddharth will now explain the block diagram.
So this is the functional block diagram where we have the input as the labeled spam and ham email dataset. And we first go through a data preprocessing phase where and after performing data preprocessing and normalization techniques, we go to feature extraction, and we use these features to train our machine learning model. And we test this model on a testing data set and get the desired classification results, and use the cross validation for performing performance evaluations such as performance metrics such as precision, recall, and accuracy. Yeah. So getting to the next slide, which is the flow of the machine learning algorithms. Machine learning algorithms which we have used are the naive Bayes algorithm, which is a probabilistic classifier, support vector machines, random forest using bootstrap aggregation, decision trees, and k nearest neighbors. And this is the flow of code where we have for example, if we have a test, I am a boy who plays, which has an exclamation mark, comma. We go through removal of punctuation, then we tokenize the word and return a list following which we perform this operation on the list elements. And then we perform stemming and lemmatization and other text normalization techniques. And then we use feature engineering to construct the required TF-IDF term frequency inverse document frequency vector, and use the training testing split for applying it to the machine learning algorithms.
So the above discussed algorithms are implemented on two different data sets, and the comparative tabular analysis is shown over here. Over here, we have measured precision, recall, F1 score accuracy for various algorithms, and and on basis of accuracy of two data set for other, which is in the next slide. Yes, on basis of accuracy, we have selected two algorithms. One is naive Bayes and the other one is support vector machine. And we have used TF-IDF, but it does not take into consideration semantic approach. So we will shift on to Jensen package for word-to-vec conversion. Now I'll describe how text classification works. So first it starts with feature engineering, where we create feature vectors, which is given as input to naive Bayes and support vector machine algorithms, which is then given pre-processed. The data is pre-processed and then converted to vector to perform various complex operations on it, and then text classification is done using Jensen package. Now Hikari will explain URL filtering.
So in URL filtering, what we first perform URL blacklisting to check if it comes from the blacklisted set of URLs. Then we perform spam word triggering for it when the trigger is set when there is a spam word, and then we use special character identification, and we use all these three together for URL filtering. So getting to the next slide, which is the process of the integration of the model, where we host the model on a cloud server and use Google Apps script to create a Google add-on on Gmail. So we basically, So getting to the next slide is the demo, which Akash will explain.
So now I will be showing the live demonstration of our project, which is the spam classifier. So we have basically created a test spit at the rate majorgmail.com, which is Gmail ID created for testing, and and as we can see currently we have 119 emails present in the inbox, and we have 0 emails present in the spam, as we can see here. This is the JavaScript code which we've written on the Google Apps script. We'll be running this code. As we can see, running function classify. Now we move on and see if the mails actually which are present in the primary inbox as spam will get classified or not. So we wait for around 10 to 15 seconds before refreshing the page in order to for the code to run. So as we can see that the code has started getting executed, and 115 emails are the emails present now in the primary inbox, and 4 emails have been classified as spam. So the code is still running, as we can see over here, running function classify. So it will take some time basically for us to run the code. Meanwhile, what we can also do is that we have created a multiple email code which can send multiple emails at one time to the code. If you just go and check here, meanwhile, sorry, if we refresh it, now we have 91 emails present in the inbox, and so this count is getting decreased as and when the number of emails are getting classified as spam. So here we have also created a multiple emails code which can send multiple emails to this account as follows. So right now we'll be sending 10 emails as mentioned over here. We'll just go and have a look at this. So the function classify is no longer running, and we have 61 emails in the inbox, and the rest 58 have been classified as spam. So which says that our project has been demonstrated. Now, as we can see that we had run the multiple emails code, and the code is yet getting executed, and we have 10 emails with this content being sent from this email ID, which is major test SPIT 6 p.m. From here till here we have 10 emails, and now if we go and check here, we have 10 emails which we have gotten here, some of which have already gotten classified. Right, so we have 10 new emails over here 6-7 p.m. as you can see. So we will just run this code again and see if these emails also get classified in real time. So the code has started running, and we had 61 plus 10 71 emails, out of which four were spam and have been classified over here as 60. So with that, the demonstration gets completed, and now I hand over the mic to Siddhant, who will start by explaining the results.
So getting to the results, we have the total number of emails sent, the spam emails and the ham emails, which have been classified as and the number of true positives, false negatives, false positives, and the true negatives. And the next set of is the accuracy, precision, recall, and F1 score which we have achieved. So this is pretty accurate for so this is the future scope. This is what we can use in the future. That is a extreme gradient boosting and other word embedding algorithms such as glove and BERT model, and we can also use real-time learning using pre-trained neural networks. Yeah.
So to conclude, I would like to say that initially text classification takes place, which is followed by URL analysis and filtering in order to determine if any present link in the mail is malicious or not. So as we discussed, 5 machine learning algorithms were used, and on the basis of accuracy, we selected naive Bayes and support vector machine, and various datasets have been referred to for a list of spam trigger pearls and a list of blacklisted URLs. And this model was hosted as an API, which was then called by JavaScript code in a Google App script in order to classify mails in real-time Gmail. So basically, a comprehensive and efficient spam classification system has been created. Thank you, everyone.
Thank you.
Thank you.